Testing, testing. How we doing? Oh, I hear myself twice? Unless that's just lag? It was just lag? Okay. And what happens if I bring up Minecraft videos again, like always? Like the
Wizard?
compact pistonless T flip
Ready.
Healer.
By that I just
2 more
mean
minutes.
testing the audio on my computer.
Warrior.
Hi, boy.
Level up your connection with AT&T Wireless and Home Internet,
Wired.
now
Oh,
available
shit.
across the nation.
I just smacked my face against the microphone.
Hello YouTube, Asuma here with a really quick and simple video on how to make a new T flip-flop. It's possible that someone else
Hello,
has come
Asuma.
up with this before, but I was making this
What if I
in
just
Minecraft
like
today,
speak
and I thought
into
I'd
the
do a quick and
microphone?
simple
Am
video
I loud?
on how to do this. So a demonstration of how it works. You can see that the timing of the repeaters when they're on full delay uses the new locking
I am, but I
feature to
could be
lock
louder.
the signal of the
Am I even louder
this
now?
repeater right
The answer
here
is
when
yes,
this
of
one
course I am. I
powered.
turned it
So
up.
if I press it again, you'll see that one turns on, and then it gets locked, and then it turns off, and it gets locked by the
Okay. Okay, that's pretty good volume. I'm gonna go to the bathroom. I'll be right back, guys. I love you, moi. What's up, guys? Ready to start. Sorry that this stream is late, as always, but also not as late as usual. No Japes tonight. I didn't hear from him, but that's okay. You guys still like me, right? You guys will still have fun when it's just me, right? You know, your boy, me. Okay. So anyway, this is the part where I pull up the code and code for you guys. But before I do that, I pull it down from from GitHub, because I forgot to do that. That only takes 1 second, I promise. Promise? See, I can distract you guys while I'm doing that. Today was Wednesday. Wait, actually, where is everything? Oh, documents, right. I always forget where I put my stuff on this computer, because I don't use this computer as often. Okay, I'm gonna open in Git Bash. I'm gonna do a Git pull. It's not gonna tell me there are merge conflicts, and it didn't. Okay, great. I'll do a quick Git log just to make sure I got everything. And I do got everything. Okay, great. Let's open a Visual Studio. Open up Visual Studio. There we go, launch. And there it is, the studio. Ignore Bashi. Bashi's not there. Nobody knows what Bashi is. You're not allowed to know what Bashi is. Yeah, we're doing good things today. Okay, so last week I showed you guys a bunch of rectangles generating that, like, cover the area being covered by another rectangle. That was pretty epic. This past week, I actually made things actively collide with each other. I'm gonna hit the run button and just get errors immediately. Did I re-target this to 10? I thought I freaking didn't do that. Oh man, we get to do that again. All right. Yeah, you .NET 10. Actually, wait. Do this properly. Go to Properties. Go to the part where it says .NET 10. Is it in Build? Okay, see, I don't like that. Don't be in .NET 10. Stop being in .NET 10. Target framework is 8. Ooh, exciting, right? Why am I getting more errors? Don't do this to me. Properties. Let's target 8, please. More errors. Okay. I like what I'm seeing. Properties. Why isn't there something being targeted? Am I doing the stupidest thing possible right now? Now, I know I have... Oh, see, some errors went away. Alright. What's gonna happen? Ah, there we go. No, it worked. We're good. Those errors... Those are the type of errors where the computer lies to you and everything is fine. Very common. Usual errors. Okay, cool. Here's my fun world where I can do lots of really cool stuff. So I've got this guy. This is like my controller guy. I can turn him. I can make him wider. I can make him taller. I can make him taller and wider. Yeah. These shapes I have not programmed actual collisions with yet, but what we saw last week was this was the collision shape, right? You guys can see that? I can make this bigger, actually. So this polygon here on the top left is the collision shape relative to the actual original PNG sprite, not the restretched, rotated one, all that nonsense. And then we got these two guys over here on the left in the middle. These are actual sprites, and so what I did this past week was fully code sprite collisions. What you need to understand is that these light green guys have pixel perfect collision enabled, and this light blue guy has pixel perfect collision disabled. Okay, so if I do fun stuff and I get really close here, you see like there's no collision happening, but as soon as I start crossing over, bam, pixel perfect collision. And yes, there's technically a little overlap here just because rotation and floating point values, it's that much of it doesn't have to be perfect. But the point is, so like, if everything is original size, then there is absolutely no error whatsoever. Then everything is actually perfect, right? It's actually amazing. But as soon as you rotate stuff, then it gets questionable. Usually rescaling, if you keep it like a whole multiple, so 2 times or 3 times or 4 times, you'll pretty much get pixel perfect collision still. This one, I guess, not quite, but it works. Trust it work. Okay, on the other hand, we've got this guy. So, oh, I hope you guys figured it out, but when there's a collision, the non-controlling object turns black. That was just a quick and easy way to show that there's a collision. Okay, so this guy, so right now he's turning black because it's detecting a collision, but remember, this one has pixel perfect collisions turned off. So if I grab this real quick, we'll do a quick print screen here. I'm not allowed to print screen. Oh, I am allowed to print screen. Sorry, I've already gotten used to Windows 11 where pressing the print screen button gives you the clipping tool. Or snipping tool, whatever it's called. Okay, so if I drag this in, and I start to make a box around this guy, so let's get a thinner line, but not too thin. Box like this. And then it's like kind of like that. You can see that the corner of his bounding box is actually barely touching the movable sprite that I was playing with. So if I like move it up a tiny bit, then yeah. So that's really important to understand that this is a full bounding box, the whole box. So even something like this causes a collision, but this does not cause a collision. Look at that, it's really cool. So those are the 2 things I did. The next thing I started doing was rectangular collisions, and rectangular collisions are basically just, well, sorry, rectangular plus, what is it? Rectangular with sprite collision, right? So I can have a rectangle colliding with a game sprite, and I want it to be able to respect its rotation, and I want it to be able to respect the sprite's pixel perfect attribute if it has pixel perfect enabled. As it turns out, that is essentially just the case where I have a pixel perfect sprite and I have a non-pixel perfect sprite. It's like the exact same thing. So I'm just making like functions that skip all of that. But also I have to do some extra stuff because with sprites, like all you have to do is tell the object I want my sprite to be rotated, I want my sprite to be a certain scale, I want my sprite to be at this position. Rectangles, I kind of had to define a whole new thing. And actually, now that I'm thinking about it, it might be worth making my own rectangle class that basically you can define a rectangle with a certain width and height, and you can define like an offset from the center. And then I can really easily treat that like a sprite. That might honestly be the way to go, because what I'm currently doing might be a little more complicated than it needs to be. At least for like an end user, because you kind of have to, if you want a rotated rectangle, you have to define a whole transformation. Wow, I need to do my vocal warm-ups. If you want a rotated rectangle, you have to do a whole transformation matrix. Like you have to, as the end user, feed the function an entire transformation matrix. So that's like the input to the function itself. So maybe it's worth making a rectangle class that just encapsulates all of that. For now, I'm gonna close everything, and I'll show you what some of that code looks like. So today won't be too terrible in the weeds, because I'll have to spend some time making a little test room that has rectangles I can play with. But it'll get a little in the weeds, because we're still doing collision algorithm stuff. Hopefully, collision algorithm stuff won't last too much longer, though, and we'll get away from that pretty soon. That'll be cool. That'll be exciting. And then we can continue to be stuck in the engine, because we're always stuck in the engine. Forever. Okay, so let's go into the engine. Oh, no, yeah, sorry. I don't take it back. I am going into the engine. I'm going into the game object class, which is here, game object. And then I have this collisions region here, which is more than 600 lines of code. And that is 600 lines of all types of collisions. And actually, I can get rid of a few lines of code. This will get deleted once I'm comfortable that everything is working and I don't need it for reference anymore. Actually, I could just delete it now. Now that I've pushed it to Git, I can get it back. That's kind of the point of pushing it to Git, but yeah, I'll wait. It's fine. I can wait. I'm patient. Patient guy. Okay. So the last thing I was working on, like I said, are these two rectangular collision methods. So we have collides with rectangle. Actually, they're both collides with rectangle, sorry. But the difference is they take a different set of arguments. So this first one lets you define just a regular upright axis aligned rectangle. You define the top left corner, you define the width and height. You can define a transformation matrix for the sprite, you can define a transformation matrix for the object that's performing the collision with the rectangle, but you don't have to, it's optional. And then I have this here, object rotated. This is set to true by default, so you can ignore it because true is if you say the object is rotated, it can be at 0 degrees, that counts as true. So being rotated just encapsulates the whole set of cases, and it's a slightly more intensive check, so it's less efficient, right? If you set object rotated to false, then you're telling the engine that you have not applied a rotation to the game object, and we can do a simpler calculation, which, yeah, it looks like this. So it's like pixel perfect. We're going to run axis aligned bounding box collides with axis aligned rectangle. So the object itself is a bounding box, and it has been axis aligned. That is the no rotation. And then we have rotated bounding box collides with axis aligned rectangle, right? And the other thing is, if you don't specify a transformation matrix, you don't have to worry about this at all. Oh my goodness. If you've not specified a transformation matrix, you do not have to worry about this rotated Boolean at all, because then we can just check if you're rotated using the object's own image angle field. So this is basically a dead giveaway as to whether or not we're being rotated. If you do pass in a custom transformation, then this field doesn't actually mean anything. I am on a work call, but I am watching with passion. Thank you very much, Coolbarrio1852. You're the best. You're epic. Okay. If only I could get... If only. Okay, no. So... yeah, as you can see, this got somewhat complicated, right? So... if our transformation is... oh, I'm sorry. This is actually the pixel perfect case, which these are not simple methods by any means. Oh. Wow. Wait. I'm sorry. I take it back. This is if the object is not pixel perfect. So these are simple by every mean. These, the next several, are if the object is... The next several are for if the object does have a pixel-perfect collider. And these get a lot more complicated. Like, mostly just the functions themselves take way more parameters. So this is actually just a single function call that's on multiple lines, and it takes, oh my gosh, so many different parameters. Like 1, 2, 3, 4, 5, 6, 7 params. And then this is the case where it's rotated. This takes 1, 2, 3, 4, 5, 6, 7, also 7 parameters. So you can never get away with it. Yeah. sorry, the point wasn't to go over these functions in detail with you guys. The point was to now run these test cases. So I need to check. Let's start with this one because this is the easier one. I can just define any old rectangle. And we say we have to check if the object is pixel perfect and not rotated against this non-rotated rectangle, right? So let's go into, let's make a new scene. Okay. We'll call this SC BB for bounding box collides with rectangles. So this is going to be a scene. So we'll inherit from scene and we'll grab our, so like this is about to change actually. The very next thing that we do is going to be messing with scenes and we're going to make a big change to them. So a lot of this is going to be different, but for now we have to run with what we've got. So I'm going to copy some of what I already have from another scene. The last thing I was testing was, so we got to instantiate, or initialize rather. Yeah, the last thing we were doing was texture collision test 2. What in the world is what? I'm sorry. It's like 5 seconds delayed, I think. Were you looking at this giant chunk of code? While I'm waiting for the answer to that, I'm going to continue what I was doing. So we go to our initialize scene, and I actually want to borrow the code from the room that I just showed you guys. I'm just going to grab all of that. We're not going to use all of it, but we're going to start with all of it. Paste that in here. We can leave the background color purple. That's fine. We're not going to use texture collision test 2. I'm going to make a new texture. And actually, I think I can just delete everything else here. So I'm going to make a new guy. But I will probably want to reuse a lot of the code in texture collision test 2 because that's the one that lets me like move the texture according to where my mouse is. That'll be good. That'll be nice. So let's go back into our texture collision test. Let's make a OBJ collides with rect test. These are kind of stupid names, but if this works, this is literally just for testing. If it works, I don't ever need to look at these objects again, probably. I don't know. Sometimes I look at them for reference. So I still try to like do a good job of making them the ideal demo, but only enough for me to know what I'm looking at. I'll make tutorials for the engine later. That'll be great. It'll be fantastic. It'll be good things. So we'll do game, SS bag, game object. Okay, Coolbarrio did not respond to asking what he was talking about with the what in the world is that, but I am getting, I want to say like a shocked emoji or twinkly eye emoji. Anyway, generate constructor. And like I said, we have to get back into, which one was it? Ah, shoot. Lost my train of thought. Right, collision test 2. So a couple of things. Reference collider. This is the guy that was following my mouse around. Oh, I can close this now. This is actually fine. Oh, and also initialize, I need to change the scene that I'm going to. So there's going to be scene BB collides with Rex. Very cool. Now I can close this as well. Let's go into here. Let's set this field, reference collider. Let's move this over here so it's easier to get to. Okay, so, all right, this is my reference collider. Grab him. So now I'm setting my reference collider equal to a new instance of one of these texture colliders, which is fine. What does the texture collider do? Nothing. Okay, so I guess everything was in the other object. That's fine. So that's actually better, because that means I can define what collisions I want to be checking for in this object, and not have to change anything in the texture collider. So right now it has the pixel perfect shape. That is totally fine. If we go to our update method, which this method is gigantic, goodbye. So I've got, this is kind of long, but basically it's like, if I'm holding control, we're going to move my object around. You know, I'm realizing the way I want to do this might be kind of silly. I don't know, I'm going to keep it this way. It kind of cleans it up, but I'm realizing, like, all I would have to do in the other scene is just not generate all of those extra shapes and generate a couple rectangles instead. But I think I'd rather keep it separate, so I'm just going to be copying this code. It's fine. Copying code is fine for test cases. Copying code is not fine for trying to make it possible to update your game ever. Yes. But yeah, so it's like, if I'm holding control, then I move the object to my mouse. If I use the mouse wheel and I'm holding 1, I rotate. If I'm using 2, I get fatter. If I'm holding 3, I get taller. Other direction, I get skinnier, shorter. Rotate the other direction. Some clamping. What? Oh wait. Am I rounding things? Oh, I just made it so that if my image scale is a whole number, it gets rid of the floating point error. That's what this is doing. So basically, if this value is close enough to the rounded version of itself, then we set it to the rounded version of itself, which will give an exact value. And we don't have to worry about floating point error when we just want to see a 3. It's a neat little trick when you actually care, but you shouldn't care 99% of the time. I don't know, it made me feel good. That's pretty much it. Just made me feel good. But yeah, okay, so this is good. So I'm going to take all of this update code and drop it in. So override, update, paste. And now if I run the game, maybe I'll see the thing. There we go, guys. Here's my console window saying that eventually we're going to load a game. Basically it. Okay, there it is. And I can rotate and I can scale things up. I'm actually a tiny bit confused. I'm not sure why I'm getting this reference sprite. What did I do to get that reference sprite? Wait a minute. Wait a minute. Does that mean I'm... Ah! Because I'm like, that reference comes up from Texture Collision 2, but I'm not in that room. But actually, when I set up this room, I didn't change the object I was creating from the other one to the new one. So this is going to be OBJ collide with Rex test. And now when I run it, I should get less things, which it's very sad, but at least it's working. I'm going to be debugging this for the next hour going, why the heck don't I have rectangles being drawn? Very cool. This is epic. Okay, so now we're going to make a couple different objects, and by a couple I do mean 2. But first we're going to only make one of the 2. Yes, that was a great way of putting that. This is going to be OBJ rect collider, I guess. Collider. I'll say AA rect collider. So this will be axis aligned rect collider, and then we'll have a rotated rect collider, and the 2 will get called by the different functions, right? So our AA rect collider, first of all, this is going to be a game object. Although it really doesn't have to be a game object. I could just loop through these and draw their rectangles. Nah, I think I'll make it a game object. It just simplifies things. I wouldn't do that in an actual game because that would be inefficient. But in this, I'm just testing collisions, so that's okay. So we'll first define, we'll do private vector2. Probably gonna have to make this not so private, but this will be top left. And then we'll have a private vector2, not top right, but instead width height. Great. So I guess I could call it size, but I'm calling everything width height. Okay. Now what I'll need to generate a primitive for this. So I will go back to my primitive test object because it shows me how to make primitives. Yippee. Although I know I added some helper functions to make specifically rectangles, right? So first of all, I do need a primitive. So private primitive wrapper primitive. And of course, we need to remember to unload those when we're done with this object. So let's just do that now. We'll do override destroy. Oop, override destroy. And this will be primitive dot dispose. And of course, we'll do override scene uninstantiate. And again, we'll do primitive dot destroy, or dispose rather. Okay, so that's out of the way. I thought these were just crudely drawn pawns, but they're made that way with the intention. I am such a fool in the presence. Yeah, they're made that way. They're made that way to be like awkward. So they've got some straight edges, they've got some curves, just to test, like, make sure the pixel perfect isn't gonna do weird things with weird geometry. Not that it makes sense that it would. I'm just checking individual pixels, but yeah, just random stuff. They are drawn that way with intention, kind of. Okay, so okay, I need to look up what to do with these primitives. Actually, wait, no. First of all, I can set my primitive. So primitive is going to be equal to new, that says, oh my goodness. Please C# Y, or I guess Visual Studio. Primitive is equal to new primitive wrapper. This takes, well, actually no. So I think what I can do here, I don't remember if I added this function, but it's like, yeah, I can do a create filled rectangle, and this does a bunch of stuff for me. That's what I thought. Game, and vertex type will be type of, so I've been just using VPC because I can never remember the name. It's vertex position color. So this is a vertex that contains both position and color. Much like how a vector contains both direction and magnitude. So, but if I type VPC, then Visual Studio autofills all of that. And then this function's kind of neat. We're just making a new primitive wrapper with that vertex type. It's going to be a triangle strip. It's going to have 4 indices, and the indices are going to be called in this order in order to make a rectangle. So that's really cool and epic. More like hole transformation. What do you mean by that? What do you mean by that? I don't understand. What? I'm gonna move on. So we're gonna say private void update primitive. Ooh, exciting. We're gonna call update primitive right here so that it happens right away. Exciting. Chat disconnected. Please wait while we try to reconnect you. Successfully connected? That's probably just a me thing. Although that could mean that I had a neato little disconnect on stream, which I'm not getting any notifications that I had a neato little disconnect on stream. I am getting notifications that I should add quizzes in my videos now. I can insert up to 10 questions with specific timestamps. Oh, are you guys ready? See all this? See all this? It's going to be on the test. That's right. It's going to be on the test. No, there's no test, I promise. Okay, so in update primitive, I'm going to update the primitive, but before that, once again, just so I don't forget, I'm going to call override update, and I'm going to call update primitive. So this happens. Oh, actually, I mean, if I'm just drawing the rectangle one time, I don't need to be constantly updating the primitive. I'm just going to not. I am just going to not update the primitive constantly. There is no reason to do that. Okay, so now if I go to my primitive test with all my examples, and I go to update primitive, we can see we've got a vector list, and I am doing the following thing. So, yeah, that's fine. Oh, actually, you know what? I 100% take it back. I do want to be constantly updating my vector list because I'm going to make this guy switch between green and black like the other colliders. So, okay, so I'm going to have a public here, public, bool, colliding, because I know I'm going to have to. I know I'm going to be calling this from. Well, wait. Forget about it. Yeah, I'm going to be calling this from within the test object, the big controller test object, so I need to make this public. And then, like I was saying, we're going to do override, update, and then updo the primitive. And that is an updated primitive. So update primitive requires the following. So we need a vertex position. Okay, so yeah, I can grab this. So vertex position color array of vertices. And I can just do this. I think this is how I'm going to handle it. And we're going to grab, what is it? This here, new vertex position color. And it takes a collection of things. So this is going to be new vertex position color. And this takes a vector3 position, which is pretty neat. So this vector3 position is really difficult, at least in 2D games. Maybe it makes more sense in 3D if your whole game is laid out this way. But basically, so if this is your game screen, right? Like, let's say this is your PC and this is your screen. So this is your PC, yeah? This is my PC monitor. This edge of the screen is like x equals -1. This side is x equals +1. This is y equals -1. And this is y equals 1. So if I want to draw a point like here, this is 0, 0. But if I wanted to draw a point like here, this is going to be 0.5, 0. And you might say like, okay, sure, that's fine. It's just a different unit. Well, it's not a different unit because, in fact, I shouldn't have even undone that. If I take my game and I change the resolution, when you move across the screen, you will not be moving at the same speed. You will be moving relative to the width of your screen, not relative to your position in the game world, which is bad. So what I've done is I've created a neat little function here. So if I do new vector3, I've created a neat little function which I use pretty much always, which is like this canvas chords to vertex chords. And unfortunately, it does require a little bit of setup and for you to know what is going on in your game at any particular time. So I would consider it to be an advanced topic, but it should pretty much always be usable. So right, so I'm going to do, this is a primitive wrapper dot canvas chords to vertex chords, right? So this is going to take a vector 2. So in my game, right, in my game world, this would be like on screen. So like if this was 0, 0, this might be like pixel, we'll say 50, comma 25. I don't know. So I'm going to give my canvas coordinates, my 50, or like, it's going to be a vector 2. So it's like new vector 2, 50, comma 25. And then I need to give it the size of the canvas. So like I was telling you, this position depends on the size of your screen. So I'm inputting the size of the screen, and it will use that to figure out where the pixel should actually go, so that it's like the same number of pixels no matter how big your view size is. So what we like to use here is the actual camera width. And since we're only going to have one camera in this test, we're going to do cameras. We're going to do cameras. Oh, see, this is the thing I've been adding, right? Cameras is technically a member of scene. So what I'm going to do is go into my game object. I've got like scene mirror members. So I want everything to be accessible that is commonly accessible without having to go through a bunch of layers of game objects, or like a bunch of layers of classes. So I don't want you to have to go through scenes to figure out what your camera is. You should be able to just go list, camera, cameras, and that's going to be a simple getter. Get, oh, and I guess it's a public list, right? Public list camera is going to be get current scene dot cameras. Okay, so as I'm coming across these, I'm going to be adding them. But like if I go to cameras here, yeah, this is also just like a getter for the cameras that's defined here. And then when you add cameras in scene with the method add camera, that's the only way to actually add cameras to that list. Okay, so now I've got cameras, and suddenly this should be legal to type. There it is. And it's mad about, right, because cameras isn't a, oh, I just wanted to check that this was actually a list. Okay, yeah. So this is unhappy because I've given it a list of cameras when in fact it wants a vector 2. So this is going to be cameras 0, the first camera, dot view size. So now it's all based on the size of the screen. And then this requires one more thing, which is going to be, oh, I'm sorry. The vector 3 requires a z coordinate, but since we're making a 2D game, z coordinate is just going to be 0. And then it requires a color, and we're going to make another value here called color in just a moment. So up here, color, and then yeah, color will be equal to, so we're going to be checking our colliding status. So if we are colliding, then color will be black, and if we're not colliding, color will be white, and color white basically says that, oh, actually, no, sorry. It'll be light green. Yeah, light green. So it'll be black or light green. And then this is fine. Okay, what did I do wrong? I'm going to zoom out for a second here. Apologize if you guys can't hear that. It says cannot convert vector 3 to vector 2. Oh, I don't know why I did this. I don't need a vector 3. I 100% take that back. What the heck? Yeah, canvas chords to vertex chord. So this does require, this returns a vertex 3 because vertex position color takes a vertex 3. But since we're only in 2D, I'm only ever going to be passing in a vector 2, not a vertex 3. Vector 3. And I'm only ever going to be passing in a vector 2. Great. Okay. But of course, this is not the actual value that I want. My vector 2 is going to be whatever I store in top left. But I can... Well, actually, no, because I don't need top left anymore, right? Since I decided to make this a game object, that'll be the built-in value, which is position. So this is going to be position. Great. And I just realized I'm going to have to make this public, so I'm going to make this public. And yeah, because I will have to access the width and height of this rectangle later when I actually want to check for collisions. I just looked over at my YouTube, and for whatever reason, it's showing me this screen. Which, I don't know. Oh, look at that. Yeah, so that really confused me for a second. I was like, what is going on? That is so far behind. What's happening? Okay, that makes sense. That's why I paused for a second. I got confused. All right, so... Right. So we're going to need a handful of values here. So since this is a rectangle, so the top left corner is going to be position, but in order to create our rectangle, we need the top left corner, so we need to go around in a circle. So if we're going to make a rectangle like this, we need to define this corner, which is going to be our position. Wow, I'm just going to type. Could not be bothered. Position. So this is position. Oh my goodness, this is crazy. There we go. This is position, and then this is going to be, I'll say P for position, and then our width, right? This is going to be our width, and I'm sorry. This would be like width, and then our Y position. This is going to be width and height, and then this is going to be our X position and height. So those are our 4 corners. So let's do that. I'm going to copy this guy. So now instead of position, we're going to make a new vector 2 and reference what I said. So we need to go in a circle. So we're going to go around like that. So this is our next vertex. It's going to be width height dot x. So x is the width part of width height. And then it's going to be position.y. Then we're going to add a new one. And since we're just grabbing the width and height, I can just simply pass in the width height. And then we're going to make one more. It's going to be another new vector 2. And like we said, it's going to be px and then height. So this will be position.x and then our width height.y, because that is the y component of our... That is the height component of our width height, stored in the y value. Okay. And this should be all of our vertices made. So we go back to primitive test, and now we have to actually set those vertices. So this will be our primitive dot set vertices, and we're going to pass in said vertices. And actually, like, I could have done something even like this, and I might as well, because it's all the same as long as I'm here. I didn't even need to have this like middleman where I set them to another value, or set a variable equal to all of them. I didn't need to make that array. I could just pass it directly into my set vertices function, since that's all I'm doing anyway. It's like literally not more readable to do it the other way. So here we go. So that's our set vertices, and this has a chance of working. So the most important thing is when I create this collider, I do have to give it a width and a height right away. I should just set something by default, right? So let's say by default, it's got a width of 100 and a height of 50. So that's our defaults. Let's go into our BB Collider Direct. Actually, no, I want to go into the... No, we'll go into the scene. So we'll do object create. This is going to be... What was the rectangle what was the object I was literally just in? Collide with Rex test, right? Collide, yeah, oh no, I'm sorry. It was AA Rect Collider, right? Yes, that's where it was. Oh, you know what? We're not going to see anything. I'm not drawing it. Draw. And if we go back to our primitive test, how do we draw things? It looks like this. Primitive.draw. Wow. Wow, that's insanely not how you spell that. Primitive.draw. Great. So again, I go back to my scene where I'm creating a new AA rect collider. Let's create it at some position. Let's go 200x 400y. I think that'll put it somewhere in the middle to the left. Let's see if anything actually gets drawn at all. You guys get to wait for the compile to finish. I also get to wait for the compile to finish, but this is my bed, I guess. It's not your bed. You don't have to wait for this. You guys can leave. I almost recommend it. Okay, so basically this is wrong. This is incorrect. I'm not sure what happened. Okay. This is simply way too tall, especially since I said... Oh, I think I know what happened, right? No, wait, that shouldn't make a difference. Hold on, let's go back to our collider. And we've got our width and height, so it should be 100 wide by 50 tall. Also, light green is kind of an ugly color. I thought it was going to be closer to this green. Maybe this is more like lime. Don't worry about me. Why is there lime and lime green? What? Why are these different? Okay, well, actually, if I hadn't done that, I could have put a breakpoint and seen what was going on. Let's see what's going on. I will be setting a breakpoint soon, I promise. That is a much better green. Okay, so if I set a breakpoint here, right before we actually run our vertices, our set vertices, let's just go into it, because, yep, that'll give us all of our... Oh, no, wait. I'm going to have to go through this 4 times, aren't I? Oh my goodness. No, I'm trying to get into this set vertices thing. Let's just put a breakpoint here and continue. Oh, cool, we're here. Okay, so the vertices that got passed in. Oh, you know what? That's kind of not helpful at all. I don't know how to read that. Okay, I take it back. Instead, what I need to do is let's look at these values. So position is 200 by 400. Oh, I found it. I found the issue. That's so silly. I'm using the width as the position. I can't do that. So this has to be like, it's got to be position plus the width gives me the right side. So it actually would be even better to just say new vector width, comma 0, because then I can just very naively add position to it. Just add the position vector. Yep. So now we've got position plus the width, comma 0. And that's going to give me this right here. So this isn't just width. This is the position plus the width. So px plus w. This whole thing, px plus w, comma py, is also just equal to the entire position plus the width, comma 0. So that's what we're doing. Then this one's going to be position plus width height. And this one's going to be position plus 0, comma height. It looks like a 6, but it's a 0, I swear. I swear to God that's a 0. Oh my goodness. 0. Good enough. Oh. Right. And I'm glad I did that because that made me realize that I also need position here. Cool. You know, I probably... Do I just have a rectangle helper? I probably do. This is probably a waste. Probably just wasted time. Anyway, there's the rectangle. It is not as toward the center as I thought it'd be, but that's really quite good enough. I'm gonna level with y'all. So, no, but actually though, do I have like primitive wrapper and then rectangle? Primitive wrapper dot. So I've got like create filled rectangle, but not like this thing. I should probably just add that, honestly. Like, I'm literally here. Let's add that. Yeah, like actually straight up, let's add that. So, so like, here we go. When I do create filled rectangle, because I have like generate regular polygon, right? And actually I should probably rename this to something like generate regular polygon vertices. And this returns set vertices. We could also public static vector2 generate regular polygon. I'm sorry, what am I doing? Generate rectangle vertices. And actually, this is actually a little painful, but I realized recently that these funny little vector2 arrays are kind of inefficient, and it's better to be passing spans. Am I willing to start passing spans? Like, what does my set vertices even look like? Oh, wait. No, wait, but if this is a... I'm pretty sure if this is a span, I'm still fine, though. If I do, like, span T... cannot be inferred. Oh my gosh, I think I'm not allowed to use spans. Thank goodness I did not want to go in and fix everything to use spans. I'd much rather just not even be... Sorry guys, just an FNA inefficiency. Nothing I can do about it. Sorry guys. No, I'm sorry. Actually, FNA is insane. It's amazing. Thank you to the FNA upkeep guys. You guys are incredible. They do it all for free. Amazing. Well, they give it to me for free. I don't know if they do it for free. They probably do it for free. Anyway, there's a lot of nonsense. We're going to generate a rectangle. It's going to be epic. Wait, what? Wait, why does this return a... Nah, I think I just took the piss. I don't think... No, I think I just don't think. That's like the main thing, right? First of all, let me get rid of this. When I run set vertices... Yeah, because this is a list of vertex position colors. I'm doing this kind of thing. I am not going to worry about it. Not going to worry about it. Not going to worry about it. Okay, so we're just going to set some vertices. So we'll do actually just straight up return and then an array of vector2s. Wow. Is going to be new vector2 u, right? And I performed a tiny lie. Oh, no, I didn't. I did not perform a tiny lie. I take it all back. I did nothing of the sort. I'm too good. Okay, so We'll do vector 2, top left. That's too many capital T's. Bottom T, lowercase t. Top left. Vector 2 is going to be width, height. And I think that's literally it. Yeah, that's the whole thing. It's going to return a bunch of vector 2s. First vector 2. Top left. Which is already a vector 2, so I didn't need to type vector 2. Top left. Then it's going to be top left plus new vector 2, which is going to be top left. That's, my goodness, my ability to type is insane. And then it's going to be, this is the exact same rectangle we went over before, so I'm not going to go over it again, but top left plus width height, WebSocket. I did the width thing again. Right, and this is going to be width height.x, not top left.x. You guys got to call me out on these things, you know. Top left plus new vector. Oh my. I said vector 2. Thank you. And there's going to be 0, comma, width height, and end my suffering. And that's it. I'm just going to delete all that. And this will now return a vector 2 with all of these things. So now if we go back to our guy, as neat as this is, I am instead going to do var vertices is equal to primitive wrapper dot something about a rectangle. Generate rectangle vertices. That's good enough for me. Top left is going to be position. Width height is going to be width height. You know what would kind of save me a little bit though? Which is a little silly. Instead of doing width height, I should do bottom right. And I don't have to do any of these calculations. I can just do new vector 2. It's more efficient. I'm not doing a singular addition. Top left dot x, bottom right dot y. Wait, is that right? No, that's not right. This is gonna be bottom right dot x and top left dot y. And it's gonna be bottom right dot y with the top left dot x. Excuse me. And this is going to be just bottom right. Wonderful. Truly incredible. Great. So now, and actually my bottom right, it's super weird. Because if I use my width and height as my bottom right value, so like let's say my width and height are 100 by 100. If I have a rectangle that starts at 0, 0, and the bottom is 100, comma 100, the actual size of this rectangle, terrible. The actual size of this rectangle will be 101 pixels by 101 pixels, which is very funny. And that is because 0, 0 is actually the first pixel. So 100 by 100 is the 101st pixel in both directions. So actually, if I want to be precise about this, I would do something very silly like width height minus vector 2.1. And this is an important distinction because I have a feeling that I'm going to have an off by 1 problem on my 2 colliding rectangles. But if I don't, then I don't. That's why I'm testing it. I'm just going to do a guess and check here. And if I do have the problem, it's a very easy case of just subtracting 1 when I do like rectangular checks. Rectangle. But I'm going to need to make sure that I test the top, bottom, left, and right of every rectangle I do. Basically. Okay. And then I don't need this anymore. Oh, I kind of need that. Hold on. So now we're going to do a for each. Well, I guess I need to do. Okay. Right. This is why I have like. This is why I had like a vertex position color. We'll say VPC is equal to new vertex position color, but this is going to be an array and it's going to have a size 4. Okay. This is now a 4 length array, and I don't know how to. Oh, right. I do have to specify that it is of the array type. Okay. And I'm going to do for int I equals 0. I know that I is going to have 4 iterations, 4 sides. So I'm just going to say, I'm just going to hard code a 4. It's fine. It's literally okay. We're going to do VPC at position I is equal to new vertex position color. And we're going to grab our primitive canvas chords, the vertex chords. Then we're going to do the vertex that we received, I suppose, which is like VPC, sorry, it's vertices. Did I name it vertices? How goofy and funny of me. How wacky. Vertices, I. And there's one more secret little thing that I didn't tell you guys about, which is that primitives don't respect the position of the camera. Can you believe that? Can you believe the disrespect? So secretly, you also have to subtract cameras, 0, because we're using the first camera, dot view position. And now it will respect the camera, but you do have to code that yourself. It's so disrespectful. Tuesday, you are 100% correct. Tuesday is always correct. I take all of my advice from Tuesday, not even as a joke. And we do cameras 0 dot view size, and we can give it the color again. And I have successfully wasted everybody's time by changing code that already worked. But this generate rectangle vertices kind of had to be done. I'm not gonna lie, had to be done. Okay, and then we're gonna do primitive underscore primitive dot set vertices, and this is going to be the VPC vertices. And once again, I'm going to run this and it's going to do the exact same thing, and you guys are going to say, wow, you sure did waste our time. Or it's going to crash or just break, in which case I'll just waste even more time. Well, it did the same thing, so at least we know what the issue is, right? Yeah, I said I was going to do that when I actually call the function, and I freaking did not. So, like I said, bottom right, you gotta do position plus. This is the part where I save my voice while it compiles. Okay, saving voice time is over. So here's our rectangle. Yeah, pretty cool, pretty epic. Let's pull it into Paint real quick, just for funsies. I want to show you guys this thing. So if I drag from, dude, why is this so hard? If I drag from corner to corner, there's a little thing on the bottom that tells me that this is in fact 99 by 49 pixels. What? I lied. Wait, what? Oh, because it's a filled rectangle. Because that's how it works. Right. When you actually, like, if you create, forgot that. So everything I said was kind of nonsense. If you draw a rectangle with primitives, like so, and you define these 4 vertices, the actual rectangle that will get drawn is, let's do that. Oh my goodness, this is so difficult. There we go. This is the rectangle that gets drawn. Like actually, where you have the left, sorry, we have the right side and the bottom side still exposed. So it makes me look silly, but I do still have to do my calculations correctly. I'm glad I checked that, because I would have not found that. I kind of just checked that to prove a point to you guys and was instantly wrong. That could have been a huge waste of time. But I will say that this still does apply. Like, the point you should be checking is one less than the position plus the width, right? The position plus the everything. And by position plus everything, I mean position plus width and height. Okay, so now if I paste this once again and get real nice and close because it's so insanely difficult to... I still missed. There we go. There we go. Now it's 100 by 100. Okay. I don't know if you guys can read the numbers. If you can't, you'll have to trust me. Okay. So that's cool. All of that just to draw the rectangle to the screen, which you'll have to draw a rotated rectangle. But no, it's chill, because all I have to do now to make more rectangles is go into... You can see why this stuff takes me forever. It's just like, to rigorously build these methods and even to rigorously build the tests, it's just pain. It's pain the whole time. Anyway, check this out. Anyway, I do encourage everybody to go programming. It's super fun. You guys should learn how to program and code and make your own games. Totally not discouraging anybody from that. Do it. Do the thing. So if I go into my scene again, I can make as many of these little rect colliders as I want. So I'm going to do var. We'll just call it an AA rect. AA rect for axis aligned rectangle. And then I can say that my AA rect, wow, I messed that up immediately. My AA rect position is going to be, well, I don't need to change the position. I can change the position right here. So let's move it over to the right a little bit, 600. But what I can do is I can say the width and height are going to not be 100 by 50 anymore. They're going to be 127 by 305, 301, because I misclicked, but that's fine. It's going to be equal to a new vector 2, like that. Okay, cool. AA rect, no AA ron. All right, fine. It can be AA ron. No, you're right. You're right. I can admit when I'm wrong, especially when Tuesday is involved, because Tuesday has never led me astray, ever. Okay, so here we go. Now that's actually gonna mess me up so hard. It's going right back to AA rect. All right, let's run it. So yeah, so now we can make any kind of rectangle of any size. Setting up primitives is, like I said, an advanced topic. It takes an extra second to draw the thing, but you can do crazy stuff with it. Also, our rectangle is immediately off the screen. Let us make he a little higher. And then we can actually run some collision code. Wow, you guys didn't think we'd get to that today, did you? I certainly didn't. Is this 127 by 300? It might be. It looks suspiciously like the rectangles that we had a second ago that were bugged. So I'm just gonna pull this into Paint real quick, and you guys won't mind if I do that, right? Because it'd be really funny if it was still wrong. And I'm gonna have to zoom out one, which in Paint means zooming out all the way we hate you. Oh my god. No, it's actually crazy. There we go. This is in fact 127 by 301. We are good. We're chilling. It'd be really weird if this rectangle worked, but this one didn't. But you always got to check. Okay. Here's the fun part. Finally. So we're going to go into our AA rectangle, whatever. And we're going to do this. No, not the AA rectangle. I'm sorry. We're going to go into the collider test object. So this is going to be, which one was it, PB? Yeah. Rect. Collides with Rex test, this guy. And in our update code, I guess after we do all the movement stuff, which I'm going to put this into a region because it's really big and annoying. Region target move literally good enough. I do not care. And region, just to make that smaller for me. Please go away. Thank you. I know you usually don't do this inside functions, but you can do it inside functions, so I'm going to do that. So here we go. It's going to be for each var AA rect in so I'm so used to this. So you just have to do like game.currentScene.getObjectList. It's like, dude, what a mouthful. So along with mirroring things from different classes, I can just do getObjectList, and it simply works because, oh my gosh, why would I make that so annoying to use? Like in my head, I thought if I made you get it from game and then scene, you'd be like, so the list resides in scene and scene comes from game. But no, you're not building the engine. You don't need to know that. Just get the list, make your game, go home. Basically, yeah. So, and then the list of objects we're getting is going to in fact be our AA rect collider. We're going to get all of the AA rect colliders in the current scene. That's what this get object list does. It gets them all of them. And then we're going to call, we got to call the collision thing, right? So let's go to our game object and see what kinds of collisions we want to test for. If I can find them. There you go. So we're starting with not that one. We're starting with this one, where we give it the top left, and we give it the width and height, and all of these other funny little things. So the first test case is the object is pixel perfect, and the object is not rotated. Oh, look at that, custom transform. There we go. It's another custom transform. Sorry, I'm catching typos in the comments I'm literally about to delete as soon as the test case works. Isn't that cool? Isn't that epic? So pixel perfect and not rotated, right? So we're gonna go in here, not you. I'm gonna close all the things that I'm not using anymore because they're so in the way and I get distracted. I don't know where things are. Oh, this is actually the object I want to be in. So our reference collider, right? We're gonna do reference collider dot collides with rectangle, okay? And then we're going to pass in the rectangle. And the way you pass in the rectangle, and this is why, like, so yeah, primitives or whatever, if you want your rectangle, but if you're just checking for like an area collision, like you're swinging a sword or something, you don't have to draw the primitive for it or anything like that. You could just define the top left and then the width and height of said rectangle and go on your day, because all that stuff is extra, right? So we're gonna do all that stuff is for visualization, but as soon as I visualize it and I think it's working, then I'm never gonna visualize it again until it breaks. And I go, why did it break? And I go AA rect dot position, because that's the top left, and I go AA rect dot width height, because that's the width and height. And I'm not going to include any of these additional transformation matrix things, because that's not the case I'm currently testing. And I'm going to say for each AA rect, I'm going to set the collider, I'm going to set the colliding equal to false. And I'm going to say, no, I don't even need to do that. Wait, I'm sorry. I could just do this. Boom. Because collides with rectangle returns a Boolean. So if we are colliding, then I'm going to set AA rect dot colliding to true. And if we're not colliding, then this sets AA rect dot colliding to false. And if we remember what that does, it turns our boy green. Depending. Let's see if it works. That should be all you have to do now to collide with a rectangle. Like, it's so simple and easy. I showed you guys all the setup for it to like visualize it. And that's not simple and easy. I also could have just used a sprite that was a rectangle, but but I got primitives working. You guys all have to deal with the fact that I got primitives working. Anyway, oh my god, it collide. And this is the important part. Notice how when it's 1 pixel away, it's not colliding. When it's directly next to it, it's not colliding. But as soon as it touches, boom, massive. And it is correctly colliding with Pixel Perfect Sprite. Fantastic. So from the top, this is perfectly next to it, no collision yet. 1 pixel down, collision. You, perfectly next to it, 1 collision, 1 pixel, right? Oh, and then there's this thing, right? I can do this because it's pixel perfect. Right here, no collision, collision. Check this guy out, different size, still working perfectly. From here, yep, that's what we like to see. From here, very good. And I can't really test the bottom because he's too tall, but it worked on the other one, so I'm sure it's fine. We go back to our game object, and we knock out this test case. Object is, in fact, pixel perfect and not rotated, and collides perfectly. What if the object is pixel perfect and not rotated, but it has a custom transformation? Oh, no! Actually, that's different from, like, if I rescale it, so I should check if, like, rescaling breaks anything, and I mean, it's not a whole transform. That's why this is like colliding, even though the pixel's not touching. Probably. I don't actually have any idea. I need like some way to see what the scale is. I'm gonna stop this, and I'm gonna write to the console what the size of our reference buoy is. Oh gosh, where's my test case? There it is. So after we do all our movement stuff, we're going to do console.writeLine, and it's going to be, I'm just going to do string literal thing, because I know how to do that now, and everyone's proud of me. We're going to do position, I don't care about the position actually. It's going to be rotation and then scale, right? So rotation, and it's going to be reference collider dot image angle, and then it's going to be a comma, and we do scale, that says scale, and it's going to be reference collider dot scale, image scale, and that should right on about do it. Needs a semicolon, everything needs a semicolon. And now we should see what's going on in the window here in our console. Here. Okay, and yep, so we can see the scale now. And if I resize him, so let's go to exactly 2, right? So this is exactly at 2. And do we have pixel perfect collisions as expected? The answer is yes. So the reason it was weird and colliding when it visually shouldn't have been colliding is because we were at an odd scale. And that's floating point problems, right? So when you are not at a whole valued pixel, then the computer still has to choose a pixel. So it just truncates it or moves it over or whatever. So you can't really be sure what, like, the collision's going to be. Okay, yeah, so that works. And also we do want to check that rotation works. Did we already check that? I don't know. Let's just... Wait, that's crazy. I'm going to say that might be an unacceptable amount of error. It should be like off by a single pixel. What is going on here? Oh no, oh that's crazy. Wait, oh, what is going on? Wait. I was gonna say it looks like it's just doing as if it wasn't pixel perfect, and be like, oh okay, I'm just calling the wrong function, but look it's clearly pixel perfect. Oh, no, that is very off. And this is completely incorrect. This should not be colliding. This certainly should not be colliding. What is going on? Oh, you know what? No, wait. No, actually what's going on? Alright, guys, this is why we run test cases. Oh, God, that's actually crazy, too. Because this is effectively what I'm doing with regular sprites. And I know this works with regular sprites, so... yeah. I just implemented this incorrectly when I went to the rectangle. So here's what I'll do. I should be able to track down the issue with relative ease. So if I go to my game object, so we're running this test case right now. Okay, this is gonna be stupid, but here. I'm gonna set a conditional breakpoint here, which is gonna make everything run slowly, but that's okay. We've got two objects on the screen. Oh no, wait a minute. Oh no, that's not gonna work, is it? Okay, here's what I'll do. I'll set a conditional breakpoint here, but it's gonna be like very funny because the condition is going to be that I run this entire function manually and that it returns true. So let's do conditions. That is our entire condition. Great. This is gonna tank. Okay. So here's our boy. Oh my god, that is the speed. That is the speed we're currently running at. Oh my goodness. The following breakpoint cannot be set, which is hilarious because in order to tell me that it broke correctly. Now, it's literally okay. I do not mind. I want to see where this is failing. So collider is pixel perfect. So obviously we get to here. Okay. Our image angle, okay, so this is the problem, right? Because before our image angle was reading as 0, so we were running this guy right here. But our image angle is no longer 0, which means we're running this. And this code clearly has an issue. Okay, so let's take a peek at this real quick. So this takes... I can't even see what the method does. Hold on, I'm gonna click on it. This takes the width and the height of the rectangle, the object that we're transforming, the rectangle's transform, the object's inverse transform, the rectangle's inverse transform, overlapping vertices, overlapping rectangle. So, right. So here's our rectangle transform. A rectangle top left, top right. Oh my god. I don't know, I'm sorry. For a second I thought it was saying like rect left and rect left I was using for both x and y. But no, it's rectangle top left dot x and dot y. Okay, so now we really do have to figure out what's going on here. And this stuff is honestly kind of brutal to debug because there's never a good way to visualize it. You kind of have to look at magical numbers and figure out what's going on. I may end up sitting here in silence while I talk about this. No, I should really be talking to you guys, right? So collides with rotated rectangle, pixel perfect. So this should be the pixel perfect version of colliding with a rotated rectangle. I'm going to get in there. This is the definition of a vector 3. That's not what I wanted. This is the definition of a translation matrix. Also not what I wanted. Get another vector 3. Get another translation matrix. And now we're inside the actual function. Fantastic. Actually great. Actually amazing. So the object's width and height we're getting from here. But that's obviously correct. We're transforming the rect to the object involves multiplying the rectangle's transform by the object's inverse transform, which does in fact look like absolute nonsense. Oh my goodness. No, what we're looking at here should be a rotation, a scale, and then a new position. That's what we're looking at. And this gives us the rectangle in the calling object local space, which is actually... Okay, wait. That might be the actual issue, which means that should this have... Maybe I should have been running into problems in the object check too. Okay, because... Yeah, if you think about it, if the object gets rotated... Oh no, I'm sorry. Obviously the rectangle is getting rotated in this situation. Okay, so the rectangle is getting rotated in this situation. I was thinking of the rectangle not getting rotated. So, transform rectangle to object, and we also have to transform object to rectangle, so we can move the rectangle. We can move the object into the rectangle's local space, and we can move the rectangle into the object's local space, depending on what we want to do. So then we're going to run Sutherland-Hodgman rectangles, okay? And this has to calculate, this has to get an overlap, so immediately we've got an issue. But I'll step into it, because I know this is going to pass. I know this is going to pass because if it failed, then we wouldn't have proceeded and we would have just returned no collision. And this is already an issue, right? So we want to get rid of this much of it. I want to see what this value returns without actually having to run it. Oh, it's going to be really annoying, isn't it? I'm actually going to have to build it because I put it on multiple lines. That does kind of suck with this. You can't like just paste a multi-line function into the watch. Oh. I didn't finish it, so it got rid of it. There you go. Now it errored. So we're going to stick this at the end. And hit enter, so it errors again. And then we're going to stick this at the end. And press enter, so it errors again. And then we're going to stick this at the end. And press enter, so it errors again. And then we're going to stick this at the end. And press enter. JK, it actually works now. Okay, value is 4. Oh, and then I need to get the actual overlapping vertices, though, as the output. Let's just go in here and see what's going on. Like, this is really stupid, but what I could do... Wait a minute. Wait a minute! Oh no, it does perform the transformation for me, haha. I was gonna say, wait, this I remember that the Sutherland-Hodgman that I used relies on there being an upright rectangle, but that's what this does. This is creating the upright rectangle, so... Yeah, so that's another reason why this is going to be so annoying to debug. Shoot. Like, hold on. If I go to the... Yeah, if I go back to this, our this screen, I want to check if this is also failing against a yeah, I want to check if this is also failing against other objects. because if it's not failing against other objects, I should be able to use that as a reference. So the scale is exactly 2, and we are rotated exactly a quarter circle. So I'm going to stop this. I'm going to go into our scene initialize and instead move to collision test 2. Collision test 2. And it is, honestly, it's entirely possible I don't figure this out in front of you guys right now. I only have 20 minutes left. But 20 minutes should be plenty, right? But yeah, the pure math is so abysmal to check. And I also am not outputting any values in this version. So I also need to output all those values, which are like right here, this console. Yeah, I'm not writing anything to the console window, so I don't know what anything is. I don't know when I'm at exactly double the size. I do know when I'm at a quarter turn though, because all the pixels become straight. Isn't that cool? Paste and run. Okay. And we wait. But in the meantime, here's my silly little console. And look at all those values. Okay, so let's rotate you to exactly a quarter. Let's increase the scale to like 2. And so like, oh man. Oh no. Yeah, that is for real. That is for real not touching. Oh. Is it a scale issue? Like if I said it's a... No, it's not even a scale issue. What is going on there? Let me set the guy to upright. It'll be easier to look at. So I'm gonna go back to my scene. Let's not rotate him at all. Let's get rid of... Oh, how do I want to do this? Yeah, let's get rid of the other one. Okay. So now this will be the exact same case as the rectangle we were looking at. Because remember, this blue guy has pixel perfect collisions turned off, so he is acting like a rectangle. And we're gonna see how bad this is. So it's like right here a collision occurs, which makes no sense. Oh, actually, no, that does make total sense, right? Because remember, rectangle. I gotta remember that, man. But anyway, so if I scale our boy up to be 2 times precisely. Okay, no, this is working. This guy's working. This guy's working fine. So it is just a problem with my rectangles. So I should be able to reference my old code. Although I did make a mistake immediately, as you guys saw in what I was looking at, or like in understanding what I was looking at. So let me just double check that I didn't make the same mistake when I was testing collisions with actual rectangles, or like using my rectangle method. The sad part of this too is I could just like tell people, no, there's no rectangle method. You have to use an object and just make it a rectangle. That'd be fine. You could work around it, but I'm trying to be nice here. I'm trying to give people extra things to work with. I'm getting punished for it. You guys are the worst boss. Yeah, no, this is... Yeah, this is clearly not correct. That is clearly not correct. Okay. This should be exceedingly easy because all I have to do is come down here and check this collision, right? So that collision is this object is pixel perfect only. So this being the calling object. The calling object is pixel perfect only, which is case 1. So that's this case. And that is going to be collides with axis aligned rectangle pixel perfect. Oh, wait. I'm sorry. The wrong collision type. No, we are colliding with an axis-aligned rectangle. Okay, collides with axis-aligned rectangle. That's not the method I'm calling, is it? I don't think that's the method I'm calling. Uh-oh. I may be in trouble. I'm colliding with rotated rectangle pixel perfect, I think. And I don't want to be colliding with rotated rectangle pixel perfect at the moment. So let's do like a... I know I can compare the same tab. Show tab in multiple... Oh no, that's not what I wanted. I mean, I do want that, but... Okay, instead what I'm going to do is I'm going to pull this guy out. And I should be able to open game. Is that like a new feature? Like you can't do that anymore? In that case, I'm just going to copy this as a comment. And by copy as a comment, I mean copy the whole thing and turn it into a comment. Okay, so here's our method. We're having problems, right? Our collider is pixel perfect. And our image angle is not 0. So we're here. And we should be running collides with axis-aligned rectangle pixel perfect, right? So what is this? Okay, and what is... Oh, now that's interesting. I just realized. Wait. The calling object is the other, right? So this is, there's no rotation. This is with rotation. Collides with rotated rectangle pixel perfect. No, okay. It's this, it is this guy. I don't know what I was thinking. Grab this. Yeah, I grabbed case 2. We're a case 1 here. I grabbed case 2 by accident. Oh, did this thing happening? This happens to me constantly. It keeps trying to add this, like, file system enumerable T result, which isn't even legal. And I keep having to go up and manually delete it. What am I doing wrong? Like, yes, it's when I accidentally paste in something, but why would you add that? Who did this? Tuesday, I need answers. I need answers. So... this is the accepted. Collides with rotated rectangle pixel perfect. Okay, it is the exact same function. But let's take a look at what's actually happening. So we've got our bound width, got our bound height of the other object. So in this case, the rectangle. Have our transform. Then we have the transform of the rectangle. It could be that this transform is incorrect. It could be that this is not what I'm supposed to be doing. Shouldn't be, though. Then we've got... yeah, then we've got our own inverse transform. And we've got the other guy's inverse transform. And then we get the overlap. Then we just take the overlapping stuff. What is going on? Why does it work here but not there? Wait, no, actually, what's going on? Just in case. So this is supposed to be the inverted matrix, right? And I'm trying to save myself from having to do an expensive matrix inversion by just building a matrix that is undoing the other one. But what would happen here if I actually calculate the inverse matrix? So we do matrix dot invert, and I pass it this whole thing. Yes, this is stupid. I should put it in a variable if I'm going to do that, but this is just a quick test. Oh, I wonder what just happened. Oh, it's including this thing that's illegal? That's really cool. Thank you for doing that. That's what I was hoping you would do. No, that's really cool. That's really nice. It's crazy. That is downright curious, isn't it? Oh. Tuesday said they stepped away for a moment, but they can answer my question. This keeps on getting added. Right here. This thing. And in fact, just in case you've stepped away again, I'm going to screenshot it and send it directly to you. Because this thing that keeps getting added inappropriately, I would say. There you go. Sent to you directly. Very inappropriate. Okay. Yeah, that looks like the type of thing I would see if it was still not working. And like, what? Wait, what is? Oh, wow. Wait. Oh, look at that. Wait, I've actually seen this before. So actually, if it's anywhere in the bottom right, then it's detecting a collision. I've seen this before, and I don't remember why it was doing that. Is that the same thing, or did I mess something up with my identity? Well, actually, more importantly, does the same thing happen with or without me explicitly creating an inversion? Because I shouldn't have to create an inversion at all. Actually, I guess asking you is kind of overkill. I literally haven't even Googled it yet. Okay, we rotate. Yes! Oh, wait, it stops like after a certain amount though, so it's not all the way. Oh, but it is like... Wait, no, actually what's going on, because when it's super far down, the small rectangle continues to detect a collision, but the large rectangle stops detecting a collision like here. Not what I would have expected. What if I bring it up? Does it ever stop detecting? Okay, it does stop detecting. Oh wait, it might be by like the same distance actually. Yeah, this is, these are super annoying. So if the rectangle, okay, basically what's happening is if the rectangle is detecting any pixel below it or to the right, we're taking a collision at the moment. So Tuesday is saying, without looking at the class in depth, Visual Studio can add missing usings when you paste something. That behavior can be disabled. Yes, I do know that, but I don't understand why it's pasting something illegal. But that's okay. Something I can look into also. You don't have to spend time on it. But it's kind of sad that just like a perfect 90-degree rotation is yielding an incorrect collision. Does it yield an incorrect collision in the other guy too? Because I was kind of hoping it would just like, that would maybe work. Because I like being able to rotate spikes and things. Not for any kind of game in particular where I have spikes that are rotated. I just like being able to rotate spikes. So if I go into... I swap it out. And honestly, I'm not going to worry about it, even if that is a problem, but I do want to look at it. So it's going to be like something test 2, right? Texture collision test 2. Yeah. Oh man. Yeah, this is why the collision stuff is super, super tough to deal with. Okay, so if this guy is rotated, whoops, this guy is rotated exactly 90 degrees. How do we do with being like right adjacent? Oh, that's gonna be really hard to detect. Okay, no. There. Wow! Wait! No, rectangles just don't work. That's crazy. No, because oh, wait. Okay, I'm actually overlapping by 1 pixel there. Haha. Well, not everything can be perfect, I guess. Okay. No, but like actually though, the rectangles aren't working. What's going on? Oh my goodness. I guess it'd be easier if I was drawing the overlapping value. Oh crap. Okay, I can do that. I can do that. Like actually drawing the thing on the top left. Let me see if I can get a rectangle inside my SC texture collision test 2 working really quickly. Let's get a rectangle in here. So first of all, we're gonna make a rectangle. So var AA rect is equal to object create. What rectangle did I make? Oh, rectangle collider. Okay, AA rect collider. And I am going to actually just get rid of everything for the moment. Goodbye. You can stay actually. That's fine. This bit you would like 600, 400. That seemed to be. Should I just put it in the same spot, right? Oh, I can smell my roommate is making something. It's making something good downstairs. Okay. Okay, I was using 600 by. Wait, no. I was using 200 by 400. So yeah, let's do. I'm gonna leave it at 600. That's fine. And why are you mad? Create takes. Oh. Why did I do that? New vector 2. Okay, so do we have a rectangle? Yes, we have a rectangle. It's about where it ends though. That's not working. Well, sorry, that one is working, but this is... I was like, for a second, I was like, oh my god, it's working? What? Room dependency? No, I forgot to add the collision check. Haha. But first of all, I need to see how we're currently returning whatever those values are, right? So... Oh, I remember how we're currently returning them. Okay. I'm going to need to do some special things for sure. So first of all, when I run this, create rotated rectangle, pixel perfect, this is where I'm currently having issues. This is going to create this overlap vertices thing right here. Yeah. I'm gonna do something really stupid, but it's literally just to get this working. We only have one rectangle, so I'm just gonna set a static value at the top here. We'll do public static. It's a span. It's a span. It's a span of, I was gonna say, I immediately forgot what the type was, but it's a span of vector 2s, and this is going to be for vertices overlap something. I don't really care. Oh, right. Okay, you can't have a span as a field, but I can just have a regular vector 2 as a field. And this will be an array. Yeah, an array. So do that. Come all the way back down here to wherever I was. Right here, you. And here we're going to say overlap vertices. I called it vertices overlap. Instantly forgot what I called it. Which is almost the same as what it's actually called. And we're just going to set that to overlap vertices. And this is going to be mad, so I have to say to array. Okay. So now I'm going to actually get the overlapping vertices. And what we're going to do is so first I'm going to go to collide with rect. And I'm going to grab the colliding for each thing. Okay. And then we're going to go to SC what? Which scene is it again? Collision test 2. With our texture collision 2. Okay, and so then when we're checking for collisions somewhere, is it an update primitives? I think it's an update primitives. Yeah, we're checking for collisions here. So I'm going to put this at the top so it's the first thing that happens. And then what we're going to do is we're going to set our overlap verts. Which is this guy. Okay. So I'm just going to say at the very bottom, right? Yeah. Let's say our overlap verts are going to be equal to, not that, game object dot vertices overlap. And we're going to say the number overlap vertices count is always going to be 4 because I haven't made a way to actually like check how many vertices there are, and that's honestly going to be fine. Yeah. So now, I don't know if this will actually work yet, but in theory we'll see the overlapping shape between the rectangle that's currently not working and our actual sprite, and maybe that'll help us determine where things are going wrong. Okay, yeah, so instant issue. Index was outside the bounds of the array, so VBC array has 25, so it wasn't that one, I don't think. Overlap verts, is it 0? Overlap verts has nothing. Oh, shoot. Okay, in that case, here's what I'm going to do. Right, because this didn't get set yet, right? So we'll do if overlap verts, this is all really silly just to get it working, but length is equal to 0. We're just going to fully return. This is one of those times where I'm going to figure out what the problem was and then have changed so much of the code that I have all kinds of other bugs. Now, but hopefully I put my tags everywhere. Okay. Like, okay. No, so that's actually what's happening. The rectangle is freaking massive. Yeah, it actually just thinks the rectangle is huge. That's what's happening. Oh, what the heck? Oh, no. Oh, wait. I know why it's making that shape. I know why it's making that shape. I wonder if I can do overlap verts count is equal to this dot length. It's making that shape because I'm forcing it to show all 4 vertices when there may only be 3 vertices in the shape. Because I don't feel like figuring out... I don't feel like making another static nonsense variable that's just going to tell me how many vertices I'm expecting to have. Yeah, that didn't even work. So, yeah. So the actual triangle is this, and then just the last 2 points are getting sent to 0, 0. But that's okay. You can still kind of realize, like, okay, this is the triangle. And that's correct. That is actually correct. The problem is the rectangle is big. Like, really big. No reason. Why is it so big? And we're going to get to the bottom of it. We're going to get to the bottom of it in the next 1 minute, because that's all the time I'm giving myself now, because it is now already past time. Okay, gaming. Oh, actually, yeah, you know the stream should be ending when the music ends. I have 2 full hours of music, and we got to the end of it for once. Been a while since I've done that on stream. Okay. Game object, rectangle width, right? No, yeah, because that's actually wild, right? Okay, if the overlapping vertices are not 0, then we know we're looking at the correct rectangle. So why don't we actually print out the rectangle width and height? Console.writeLine rect with height. And spoiler, this is going to be the wrong size. Unless it's not. That'd be insane. That'd be wild. So here's our output. This is going to go by really quickly, but I will pause it in a second. Oh, right. I'm like, why is it suddenly working? Okay. It is currently 700 by 450. Right? And if we go to the call, which is here, wait. No. Okay. I don't know. I got freaked out for a second. If I go to the call, which is here, boom. What am I giving for the bottom right? And what does this take? This takes a width and a height. And I'm giving it the bottom right value, and not the width and the height. It's so painful. No, it's actually so painful. Okay, fine. What's my width and height then? Oh, it's just a value that I already had and forgot about? That's crazy. Now, isn't that just insane? Isn't that so cool? It's a good thing I made that visualizer, because I'd be so terribly lost all the time. Width, height. Gosh. And you. Width, height. Can't believe I thought, like, rectangle will probably work. I don't need to test any of this. It's laziness. Pure laziness. Because I don't want to deal with literally this. The fear that anything goes wrong, and it takes me exactly 29 minutes to solve. Oh my god. Alright. First world problems aside. That's so cool! Wow! And oh. What if it's twice the size? Oh my goodness. There's a little bit of overlap there. There's it's just a whole pixel of overlap, which is kind of telling me. Maybe it's not telling me anything. I don't know. I'm gonna. May I pretend this is working fine? I don't know. Yeah. Yay! Freaking rectangles, dude. Oh my goodness. So now if I set the scene back to the other scene, AABB rectangle collider. Okay, cool. Oh, that's not a scene. Scene collides with Rex. Good enough. Collides with Parks and Recs. You guys enjoying the music? Okay, here he is. Same nonsense as always. Oh my gosh, it work? It working? It work? You've got to be kidding. It work? What is this nonsense? It work. What if I make him twice as big? It works still? It still work? Oh, come on. You guys are being too nice to me. Okay. I hope you guys had a enjoyed the stream. I didn't bring water with me, and I regretted it, because my throat hurt. Okay. Thank you for joining the stream. Have a good night, everybody. You're all the best. All of you. Every single one of you. The best.